Imagine a universe so vast, so ancient, that it existed for billions of years without a single conscious eye to witness it. No human, no alien, no being capable of thought or observation. For all that time, was it truly there? Or was it merely a potential? A cosmic blueprint waiting for a mind to bring it into being? It's a question that sounds like philosophy, but it's rooted in the deepest mysteries of quantum physics, challenging everything we think we know about reality itself. For centuries, science has operated on a simple premise. The world exists independently of us. We observe it, we measure it, but our act of observation doesn't create it. A tree falling in an unobserved forest still makes a sound, right? But then, over 100 years ago, we peered into the quantum realm, the bizarre subatomic world that underlies everything, and found something deeply unsettling. Something that suggests reality might be far more fragile, far more dependent on us, than we ever dared to imagine. The heart of this mystery lies in a phenomenon called wave-particle duality. Think of light, or even an electron. When we're not looking, it behaves like a wave, spread out, indistinct, existing in many places at once. It's a blur of probabilities. But the moment we try to measure it, to pinpoint its location, it instantly collapses into a definitive particle, a single fixed point. It's as if the act of looking forces it to choose its reality. The famous double-slit experiment demonstrates this perfectly. Fire electrons at a screen with two slits. If you don't watch them, they act like waves, passing through both slits simultaneously and creating an interference pattern on the detector, like ripples in water. But if you put a detector at the slits, to see which one the electron goes through, suddenly it behaves like a particle, choosing only one slit. The interference pattern vanishes. The mere act of observation fundamentally changes its behavior. This isn't just about tiny particles. It suggests that reality, at its most fundamental level, isn't fixed until it's observed. Before observation, it exists in a state of superposition, a blend of all possible outcomes. It's neither here nor there, neither wave nor particle, until a conscious observer forces it to pick. So, what exactly constitutes an observer? Does it have to be a human mind, or could a measuring device, even an atom, do the trick? Some interpretations of quantum mechanics, like the Copenhagen interpretation, suggest that consciousness plays a crucial role. Not necessarily human consciousness, but any system capable of irreversibly recording information. Without such an interaction, the quantum world remains a realm of possibilities, not actualities. This takes us back to our initial question. If the universe began as a quantum soup, a vast ocean of probabilities, what brought it into its concrete existence? If everything starts at the quantum level, and quantum states require an observer to become real, then the entire universe, in its earliest moments, would have been a sea of unobserved possibilities. Was the Big Bang itself just a potential, an unmanifested cosmic event, until the first conscious entity, even a very primitive one, arose to see it? The thought is dizzying. Did the universe wait for us to exist, to truly exist itself? Think about the billions of years before life emerged on Earth, before the first single-celled organisms, before the dinosaurs, before anything that could remotely be considered an observer. For all that immense stretch of cosmic history, was the universe just a collection of statistical likelihoods? Did the ancient stars burn with a maybe light? Did galaxies collide in a perhaps reality? It seems absurd on the surface, doesn't it? This is where Schrödinger's cat comes in, a thought experiment designed to highlight the absurdity of applying quantum rules to our macroscopic world. A cat in a box with a quantum trigger that might release poison. Until you open the box and look, the cat is supposedly both alive and dead simultaneously. But common sense screams, the cat is either alive or dead, regardless of whether we're looking. The act of observation can't be creating the cat's fate. This is the crux of the problem. The quantum rules seem to break down when we scale up. A quantum particle needs an observer, but a planet, a star, a galaxy, they seem to exist quite robustly without our attention. So where is the line drawn? At what point does quantum fuzziness solidify into classical reality? This is called the measurement problem, and it's one of physics' most enduring and frustrating puzzles. One theory, the consciousness causes collapse model, takes the idea of observation quite literally. Only a conscious mind, capable of self-awareness and interpretation, can truly collapse a quantum waveform. This would mean that before any conscious life arose, the universe existed as an uncollapsed, probabilistic state. Our very existence, our capacity to observe, would be what solidified reality. But this idea has profound implications. If consciousness is necessary for reality, what about the moments when no one is looking? Does the moon vanish when you turn your back? Most physicists find this deeply unsatisfactory. This led to another, even more mind-bending solution: the many worlds interpretation. Here's where the story takes a wide turn. Instead of the wave function collapsing into one reality when observed, the many worlds interpretation suggests that every possible outcome of a quantum event actually happens. Each time a quantum choice is made, say an electron goes left or right, the universe splits. Every observation doesn't collapse the wave. It simply causes our universe, our branch of reality, to follow one path, while countless other universes branch off to follow all the other possibilities. In the many worlds interpretation, the universe doesn't need an observer to become real. All the possible realities already exist, constantly branching and evolving. The moon is always there, in countless versions of reality. Our act of observing simply determines which branch we find ourselves on. This sidesteps the consciousness problem entirely, but it introduces its own profound question. If every possibility plays out, what does that mean for our own unique existence? So, which is it? Does consciousness bring reality into being, or are we just surfing one wave among an infinite ocean of parallel universes? Neither answer is intuitively comfortable, yet both are deeply explored by serious physicists. It highlights how little we truly understand about the fundamental nature of existence. The universe isn't just out there. It might be intimately tied to our very perception of it. But let's consider a less radical, but equally profound perspective. Perhaps the question, did it exist, is the wrong one. The universe in all its quantum glory existed as a tapestry of probabilities and interactions from the very beginning. Its reality wasn't dependent on an observer to create it, but to define it, to bring certain possibilities into sharp focus. What if observation isn't just about consciousness, but about any interaction? Every photon bouncing off an atom, every particle collision, every gravitational pull, these are all measurements of a sort. They collapse quantum states by causing irreversible changes and establishing correlations. In this view, the universe has been observing itself through its own internal interactions since the Big Bang. The universe, from this perspective, didn't need us to be real. It was always unfolding, always interacting, always establishing its own reality through its intricate web of causal connections. The stars ignited, the galaxies formed, the planets coalesced, each event a measurement on a grand cosmic scale, solidifying potentials into actualities. We just happened to arrive late to the cosmic party. However, our arrival wasn't insignificant. While the universe may not have needed us to exist, it needed us to understand it. Our consciousness allows for a unique level of observation, not just a physical interaction, but a conceptual one. We don't just collapse a wave function. We interpret it, we question it, we build theories around it. So, to return to our original question, was the universe just a concept before we looked? Perhaps it was neither a pure concept nor a fully defined classical reality. It was a potential, a symphony of possibilities, constantly playing itself into existence through its own interactions. And then billions of years later we arrived, not to create its reality, but to shine a light on its deep, inherent nature. Our role isn't to create the universe, but to be the universe's way of looking at itself. We are part of the vast, intricate web of interactions that define reality, and our consciousness adds a unique layer of meaning and inquiry. We transform raw data into understanding, probabilities into knowledge. The universe was there, in all its quantum glory, waiting for minds like ours to interpret its grand, unfolding story. The universe didn't begin as a concept, but it became a conceptualized reality the moment intelligent life began to ponder its existence. Our questions, our theories, our observations, they don't bring the universe into being, but they bring its incredibly complex, nuanced reality into our awareness. They make its silent, ancient existence profoundly meaningful. So, while the universe certainly existed before any human looked at it, its existence was a different kind of existence, a realm of quantum potentials and inherent interactions. Our observation, our consciousness, didn't create it, but it illuminated it, giving it a new dimension of observed reality and understanding. We are the lens through which the universe sees its own magnificent face. The deeper we delve into quantum mechanics and cosmology, the more intimately intertwined the observer and the observed seem to become. It suggests that our presence, our consciousness, isn't just an accident in a cold, indifferent cosmos, but an integral part of its unfolding narrative. We aren't just in the universe. The universe is, in some profound way, within us. Ultimately, the universe was always there, in its own quantum way, but it needed us, the observers, to ask the questions, to formulate the theories, to transform its raw, energetic existence into a story, the story of everything. We didn't create it, but we made it mean something. What other hidden realities are waiting for us to shine our conscious light upon them?